Hey everyone, I want to show you a project I've been working on for quite a few months now. It's called the PiGRRL Zero Advance. This project is actually named after the original PiGRRL Zero project that the Ruiz brothers from Adafruit designed when the original Pi Zero came out. This was back in, I believe, 2015, 2016. After that, I then modified their original design and came up with a design that had audio, and then a further design of the PiGRRL Zero Plus that actually adds audio and a larger screen from a 2.2 to a 3.2 inch screen, called like I said, the PiGRRL Zero Plus. This design here is actually in the same spirit as those original designs. However, it completely redesigned it from the ground up. So we're looking at basically a brand new project design completely from scratch. Ever since the original PiGRRL Zero, I've been keeping this list of modifications that I'd love to see added to the design. I also followed a lot of other people on Thingiverse that had great ideas about their projects, and ultimately kind of took some of those, incorporated some of those ideas, and tried to really pull them in to make this awesome project idea work. So I had a few goals in mind for the project. First of all, I wanted this design to be easy to build. I didn't want this to be a complicated design. I wanted, it takes a lot of time and patience to get that PiGRRL Zero Plus design to work. The Pi Zero to the Pi TFT connection was actually kind of difficult. It wasn't an easy connection to do, and so I really wanted to eliminate some of these points where the design could actually intimidate people from building it. Second, I wanted to incorporate more features into the design. I'll kind of talk about a lot of those features later. Third, I wanted to make the design slimmer and sleeker and just really more professional looking, which is, I think I've accomplished all three of those goals really as part of this project. So let's run down through a few of these changes. So the first thing you'll notice in the design is it's a lot thinner. In fact, it's a lot thinner than the original design and the Plus design. So you can see here's the thinness of the case. This is actually the PiGRRL Zero Plus, and then this is the original PiGRRL Zero from Adafruit. So you can see tremendously thinner than these other two designs. I was able to cut the thickness of these two designs from over an inch down to about 3/4 of an inch or 0.8 inches. May not seem like a lot from a numerical standpoint, but it's actually quite a bit. Makes the design just a lot easier to put in your bag, or it's a lot nicer to feel in your hand. So it's a much better design. You also notice some of the trim and the cut on the case is a lot different. So first of all, I wanted to use real SNES buttons. You'll see here I've used the SNES A, B, X, and Y buttons, as well as the D-pad. I want to just use real buttons, as that's a superior design versus a 3D printed button like this one here. So you can see there's just a tremendous difference there in quality and usability for gameplay. Another component of the project that you'll notice right away is that the screen size did change. So if you have a PiGRRL Zero Plus, you'll notice a little bit of a change, but definitely a big change from the original PiGRRL Zero, and that the screen on this is actually 3.5 inches across. So the original PiGRRL Zero was a 2.2 inch screen. My redesign, the Plus model, was actually a 3.2 inch screen. So now we're going up to a 3.5 inch screen. What's actually really interesting was it wasn't until about early 2018 where this screen itself, the 3.5 inch screen, was practically unusable for RetroPie and playing any kind of emulated game on. The FBCP drivers that were kind of originally established with Adafruit and mainly with RetroPie to develop this project, they didn't work very well with the screen and had a lot of frame rate drops, had a lot of screen tearing. And it wasn't until I found this driver by Juju on GitHub called FBCPILI9341. I'll put the link in the show notes or in the notes for this video. The driver basically replaces the original FBCP drivers, and this thing has amazing performance. So now we've taken a screen that pretty much was unusable for a project like this, and we've made it usable. I will say the design has a ton of other items here, including you'll see there's audio inside, so we got speakers for the bottom. We've got headphones on the top. We've got HDMI out. You got the standard HDMI on the side, which I have an HDMI port in the works for to cover it, so you can just cover this up if you want. You'll notice the power buttons have actually have push buttons, so you depress it and it works. Here, I'll show you on this one here. So the power button is simply just a simple press to turn it off and on. You'll also notice that I have the traditional looking kind of, I guess, in the spirit of what Nintendo would do for their start and select buttons at the very bottom, kind of set up in this configuration. Kind of a neat way to do it. You also notice we could put an LED in here for power and understanding whether your battery's getting low on power. I'll talk about that in a few minutes. There's a ton of things you can do when you redesign a project like this from the ground up. You can think about placement of power button. You can think about placement of the HDMI ports. You can think about where you want your charging port, which is actually on the bottom here. Adding that LED for indication. Actually, the neat thing with the LED indication is it's actually got a transistor resistor built into the inside that allows me to display in the top corner a battery icon when your battery's low. So that's just another add to the project to kind of help just enhance it. In order to get a project like this to work, to get the thinness and to get something like this to work, you had to come up with something like a custom PCB design to make it really happen. So what I came up with was this custom PCB that allows you to basically place all components on it, and it kind of eliminates the issue of understanding, it eliminates the wires, so it eliminates the thickness of the case you need, so it basically puts all the wires in the PCB. But it also eliminates a lot of failure points in the fact that now you just solder it to the PCB. You don't have to worry about, well, did I plug the right wire into the right GPIO slot, or did I do this correctly? Now it's very simple. Plug, solder, place. It's a tight fit, so you're going to have to make sure you have it put together really tightly. It means you're going to have to be tedious in your design, but ultimately this is going to eliminate a lot of failure points in people's designs. I will be printing them. I'll put out the design so everybody can have this if they want to take a look at it. But printing these it typically requires you to print them in bulk. That's where you get your best deals. So I'm actually going to buy a bunch in bulk and then go ahead and I'll throw them up on my website. I'll put a link down to the bottom of this video. You can just go out there and grab one of these. I'll end up putting them out. You guys can just grab one. I'm not trying to mark things up or anything like that. I'm pretty much selling these things at cost. So take a look and like I said, it'll be down in the bottom of the video. Also, the instructions for how to build the project I have on my website. It's 3D spelled out 3dprintspace.com. There's a full-on build instructions how to build this project. So feel free to use that guide as you work through the build as well. If you have any questions of the guide, give me a comment, shoot me a comment, or shoot me an email, or hit me up on Twitter. I can make changes to the guide and try to enhance it to make it easier if people have questions specifically about the build. But I think it's a pretty comprehensive guide, very similar to what Adafruit puts together for their guides as well. Like I said, I'm super proud of this project. It's been a lot of time. It's been over a year in the making now from when I first started it. I've dumped several hundred hours of my time and literally hundreds of dollars in resources on a project like this. It takes a lot of time and effort. I really want to work on some more projects. I have this really neat idea to do something with the new Hyperpixel. This is the new Hyperpixel 4-inch. I have a neat idea for that. I also want to do a micro design as well, and maybe come up with a micro design. I want to keep all my designs, user friendly and make them easy so people, aren't intimidated by the project. And I also want to make them common to what, parts and easy to grab parts. And typically Adafruit has those parts, which are really easy to use and find and supported. So, but I want to keep doing these projects, and I think in order to do that, though, I really need support from people that are interested in these projects. So if you really want to help support this or my next project, go ahead and consider donating to my Patreon page. I'll have a link down below in the video as well. And then anything you can contribute would be super helpful. I just really appreciate everybody's feedback. I've had a lot of feedback on Discord, on our Discord channel, talking about this project. So I really appreciate everybody's feedback. I'll link in my guides all of the all the credits to the people that have the designs that I've utilized. So a lot of the designs, like the drivers for the video, I'll link all of that, crediting everybody that's involved with these projects. So I thank everybody. Obviously, open source stuff is everybody as a community working together, and I still really support that and really appreciate everybody's involvement. So thanks for stopping by, and don't forget to upvote and subscribe to the video, and we'll catch you next time. Thanks.